Axions? Phantom energy? Astrophysicists scramble to patch a hole in the universe, rewriting cosmic history in the process. There was, you might say, a disturbance in the force, long ago, when the universe was only about 100,000 years old, a buzzing, expanding mass of particles and radiation, a strange new energy field switched on. That energy suffused space with a kind of cosmic anti-gravity, delivering a not-so-gentle boost to the expansion of the universe. Then, after another 100,000 years or so, the new field simply winked off, leaving no trace other than a speeded-up universe. So goes the strange-sounding story being promulgated by a handful of astronomers from Johns Hopkins University. In a bold and speculative leap into the past, the team has posited the existence of this field to explain an astronomical puzzle. The universe seems to be expanding faster than it should be. The cosmos is expanding only about 9% more quickly than theory prescribes. But this slight-sounding discrepancy has intrigued astronomers, who think it might be revealing something new about the universe. And so, for the last couple of years, they have been gathering in workshops and conferences to search for a mistake or loophole in their previous measurements and calculations, so far to no avail. If we're going to be serious about cosmology, this is the kind of thing we have to be able to take seriously, said Lisa Randall, a Harvard theorist who has been pondering the problem. At a recent meeting in Chicago, Josh Freeman, a theorist at the Fermi National Accelerator Laboratory in Batavia, IL, asked, "At what point do we claim the discovery of new physics? Now ideas are popping up. Some researchers say the problem could be solved by inferring the existence of previously unknown subatomic particles. Others, such as the Johns Hopkins group, are invoking new kinds of energy fields." Adding to the confusion, there already is a force field, called dark energy, making the universe expand faster. And a new, controversial report suggests that this dark energy might be getting stronger and denser, leading to a future in which atoms are ripped apart and time ends. Thus far, there is no evidence for most of these ideas. If any turn out to be right, scientists may have to rewrite the story of the origin, history and, perhaps, fate of the universe. Or it could all be a mistake. Astronomers have rigorous methods to estimate the effects of statistical noise and other random errors on their results, not so for the unexamined biases called systematic errors. As Wendy L. Friedman, of the University of Chicago, said at the Chicago meeting, the unknown systematic is what gets you in the end. Generations of great astronomers have come to grief trying to measure the universe. At issue is a number called the Hubble constant, named after Edwin Hubble, the Mount Wilson astronomer who in 1929 discovered that the universe is expanding. As space expands, it carries galaxies away from each other like the raisins in a rising cake. The farther apart two galaxies are, the faster they will fly away from each other. The Hubble constant simply says by how much. But to calibrate the Hubble constant, astronomers depend on so-called standard candles, objects, such as supernova explosions and certain variable stars, whose distances can be estimated by luminosity or some other feature. This is where the arguing begins. Until a few decades ago, astronomers could not agree on the value of the Hubble constant within a factor of 2, either 50 or 100 km per second per megaparsec. A megaparsec is 3.26 million light-years. But in 2001, a team using the Hubble Space Telescope, and led by Dr. Friedman, reported a value of 72. For every megaparsec farther away from us that a galaxy is, it is moving 72 km per second faster. More recent efforts by Adam G. Rees, of Johns Hopkins and the Space Telescope Science Institute, and others have obtained similar numbers, and astronomers now say they have narrowed the uncertainty in the Hubble constant to just 2.4%. But new precision has brought new trouble. These results are so good that they now disagree with results from the European Planck spacecraft, which predict a Hubble constant of 67. The discrepancy, 9%, sounds fatal but may not be, astronomers contend, because Planck and human astronomers do very different kinds of observations. Planck is considered the gold standard of cosmology. It spent 4 years studying the cosmic bath of microwaves left over from the end of the Big Bang, when the universe was just 380,000 years old. But it did not measure the Hubble constant directly. Rather, the Planck group derived the value of the constant, and other cosmic parameters, from a mathematical model largely based on those microwaves.